A-level specification, Mathematics A for OCR. So yesterday we did indices and we were able to use all the laws concerning indices, and today we're going to be moving on to Surds 1.02b.
So what is a surd?
Well, a surd,
the ones we're going to be working with in A-level anyway. It's essentially just a square root. So if you have square root A, well, I have a false habit of saying this is square root A, because these are the same thing. And we've got a cube root here, that's the same thing as saying 1 over 1/3, A over 1/3, A to the power 1/3. For example, if we have root 9, we can split that up to root 3 times 3, and the side of surd, when you have something times itself, you can just cancel out the surd and get the one thing back. There's only two laws you need to know with surds. That's the multiplication law and the division law. So when you multiply two surds together, all you have to do is multiply what's inside them. So root A times root B will give you root of AB. When you divide two surds, it's the same story, but just a different chapter. So you have root A divided by root B, that will give you root A over B. As a bonus rule, adding surds doesn't really do anything to it, unless they have the same base. But if they have different bases, nothing happens. Let's just explain what I mean by the same base. So if you have root A times plus root A, we'll get 2 root A. So what are some applications of surds? Well, like we mentioned earlier, if we have root A times root A, we'll just get A. The square root of A squared is A. And as a, as a bit of an extension, I'm going to show what happens when you have A cubed over B squared and you root it all. You're free to split up the roots, and you're also free to express the root as something else. So if you have the square root of A to the power of 3, you can just express that as A to the power of 3 over 2. Like we said, from A, if you have anything squared and you take the root of it, you get B. Here we have A squared over B and the root of it. Again, we're free to split up the roots, and we'll get the root of A squared over root B. Now here is what we call rationalizing. When you have a root on the bottom and it asks you to simplify it or rationalize, you essentially just multiply it by itself. So this number here is equal to 1, and I've just multiplied this by 1. When you multiply something by 1, you don't change it. Why is this 1? Well, root B over itself, we know that anything divided by itself is equal to 1. Now, we've got B times root A squared. That'll just simplify to root B times A. On the bottom we have root B times root B, which is root of BB, which just simplifies to B. We've just rearranged it, and we get A times root B over B. Again, to rationalize, you just multiply by 1, but that 1 will be what you have on the denominator, on the numerator, and the denominator. Examples of this. Well, examples of just surds in general. Here we have root 2 times root 3. We just multiply what's inside and you'll end up with root 6. Root 3 times root 26 will give you root 78. Root 5 times root 2 times root 10. We're going to do it one by one. So 5 times 2 is 10. 10 times 10, well, root 10 times root 10 is root 100, which is just 10. Here we have 2 over root 5. So we've multiplied it by 1, which is root 5 over 5. And we've just simplified. So 2 root 5 stays how it is. Root 5 times root 5 is root 25, which also simplifies to 5. Here we've got 20 times root 3 over root 10. Again, we've multiplied it by 1, being root 10 over root 10. And we're just going to simplify. Root 10 times root 10 is 10. And 20 root 3 times root 10. Well, you multiply what's inside the surds and you get 20 times root 30. Simplify this a little bit further. We can cancel out the 10. This is 2 times 10. That's why the 10 gets cancelled. You'll just end up with 2 times root 30. So, here's some further questions, just to basically make our life a little bit harder. That'll be useful for the exam. So, here the question says to simplify and rationalize a over b plus c root d. Now, we're still going to be multiplying by 1. However, we're going to do the conjugate. I don't know if it's actually called conjugate for surds, but I'm going to call it a conjugate, because that's what we do for complex numbers. Well, the conjugate of b plus c root d is b minus c root d. Multiplied it by 1. And this is the result over here. A times b minus c root d. In the denominator we have b squared plus, well, I've actually multiplied it as if it were brackets, because that's how you're meant to multiply it. You'll get b squared plus c root d minus c root d. This is the main reason here for why you want to multiply it by the conjugate and not the actual number itself, because it makes the surd and the button on the denominator disappear. Because here you have minus c squared and you're squaring the remaining surd. As a result over here, you'll see that the surd has disappeared from the denominator and thus it has actually been rationalized. On the denominator, you just resolve as you normally would, with a times b being ab and a times minus c root d being minus ac root d. Here we've got an example of numbers. So let's say we have 3 over 10 minus 2 root 5. We're going to multiply it by 1. You'll see that we get 3 over 10 minus 2 root 5 times 10 plus 2 root 5 over 10 plus 2 root 5. We'll give you this, 3 times 10 plus 2 root 5. And on the denominator, we get 10 squared plus 2 root 5 times 10 minus 2 root 5 times 10 minus 2 root 2 multiplied by the square root of 5 squared. Simplify that, you'll get 30 plus 6 root 5, because 3 times 10 is 30 and 3 times 2 root 5 is 6 root 5. 10 squared is 100. These two cancel out. And 2 squared is 4, and root 5 squared is 5. Opening this bracket up, you get minus 20. Then here, 100 minus 20 is 80. And we haven't done anything to the numerator yet. I've subbed out 2. Let me scroll up a little bit. I've subbed out 2 out of both the numerator and denominator. That's just going to cancel out. Then you'll get 15 plus 3 root 5 all over 40. Go down a little bit further. We have 3 plus root 2 over 4 plus root 3. Now I just want to show the bonus rule that we were talking about earlier in action. Found that this was the best way, because this actually utilizes everything we've learned today and the bonus rule too. So we have 3 plus root 2 over 4 plus 3 rooted. We multiply by 1 over here. 1 being 4 minus root 3 over 4 minus root 3. We choose this because it is I've forgotten the word. The conjugate, that's it. It's the conjugate of the denominator of the original fraction. We're just going to simplify it as we normally would. So 3 times 4 is 12. 3 times minus root 3 is 3 root 3. Well, minus 3 root 3. Root 2 times 4 is 4 root 2. And root 2 times minus root 3 is minus root 6. For the denominator, we get 4 squared, which is 16, then 4 plus root 3, and 4 minus root 3, and we get minus 3 times 3 rooted. This simplifies to 16 minus 3 on the denominator, and on the numerator, well, nothing happens because there are no like terms, and here's where the bonus rule comes in. You cannot add or subtract surds that do not have the same number inside. You can't really do anything there. So, all this simplifies to is 12 plus 4 root 2 minus 3 root 3 minus root 6 all over 30.
And that's that for today's video. We've gone through 1.02b. Tomorrow we'll do, well, on Monday, because tomorrow's Saturday, we're going to be doing simultaneous equations. If you liked today's video, like, comment, subscribe, and leave a comment if you got any suggestions. Thank you for watching.